Hello everyone, welcome to the online session, an initiative by the Department of Collegiate and Technical Education. This is session number 8 and I am Kirti. I am a lecturer in Civil Engineering Department in Government Polytechnic Chanasandra, Bengaluru. I hope you all have watched the previous session, session number 7, because this particular session, session number 8 is going to be the continuation of the previous session number 7. So going ahead, I will be doing a quick recall about the last session. In the last session, we had covered some of the topics like introduction part, what is dampness, how what causes dampness, and the definition of dampness and the causes of dampness. Like the important causes were mainly rain penetration, climatic condition, defective construction material, and defective construction, and entrapped air inside the building, moisture originating in the building, level of site, drainability of the soil, and many more other causes were covered in the previous session. For the detailed information, please refer to the session number 7. Going ahead, in this particular session, we would be discussing about these many topics: effect of dampness, methods of prevention of dampness, and some of the multiple choice questions regarding the same topics and the references. So, coming to the first part of the session, effect of dampness. So, the building materials such as bricks, timber, concrete, etc. have moisture content in it, which is not harmful under normal situation. But if the moisture content rises beyond the certain level where it becomes visible and it causes deterioration, this leads to dampness. Moisture content of different material may be same, but the acceptable limit differs from material to material. For example, if the 10% by weight water content in timber is not might not be harmful, but 10% by weight water content in brick is dangerous. It is harmful because the saturation limit for the brick is high. So dampness is more. So water content ratio percentage is same, but from material to material, the dampness effect of dampness is different. Moving on, a structure is badly affected by the dampness. So let's see what are the effects of dampness. The first effect, it causes rots to wooden members in the building. So we are going to use a lot of wooden members in the building, like window frames, door frames, and also nowadays we use wooden flooring as well. So dampness is going to it is going the wooden members are going to get rotten because of the dampness. That is the first bad effect or the ill effect of dampness. The second effect is that it causes corrosion of metals in the building. So we are going to use a lot of metal in the building. We are going to use the reinforcement in the building. So that is going to get affected by the dampness. Dampness gives rise to breeding of mosquitoes and creates unhealthy conditions for the occupants. So this unhealthy condition may lead to a lot of diseases. And moving on to the next point, dampness also creates unpleasant patches in the building. So this patches may be formed on the walls or the ceilings because of the dampness, which is not very pleasant to look at for the occupants. The next point is the dampness can also fail the electrical fittings, which may lead to electricity leakage and also short circuiting. Dampness promotes or it can also accelerate the growth of termites, which in turn affects the wooden members in the building. Dampness also results or it also affects the plaster, which results in softening and crumbling of plaster. Okay. The next point is it may also cause bleaching and flaking of paint with formation of colored patches. Dampness may also cause efflorescence, which may lead to disintegration of bricks, stones, tiles, etc. In this particular picture, you can see that dampness has caused flaking of paint and also there is deterioration of the member, structural member. Floor covering may also get seriously damaged because of dampness. The floorings may get loosened or it can also get damaged because of dampness. Dampness breeds germs and other dangerous diseases like tuberculosis, and the occupants in the particular building may also get asthmatic. So these are some of the effects of dampness, and some of the other effects may be warping and buckling of wooden members, dry rotting of timber. These are some of the other effects of dampness on the building. Here are some of the pictures showing the effect of dampness. In the first picture, you can see that there is flaking of paint, flaking of crumbling of plaster. And in the second picture, you can see that there is blisters formation, or you can also see the efflorescence. In the third picture, you can see the colored patches on the wall and on the ceiling as well. So moving on to the next topic, methods of preventing dampness. Okay. The first method is by providing DPC. In the last session, we have already discussed about damp proof cores. To prevent the water or moisture content entering inside the building, we provide damp proofing to the building. Okay. So, what is damp proofing? In this method, we are introducing a water repellent membrane which is a continuous layer of impervious member which is provided in between the source of dampness and the part of the structure exposed to dampness. It consists of the damp proofing material which we are using here is a flexible material which may contain bitumen, mastic asphalt, bituminous felt, polythene sheets or metal sheets even. Damp proof course is provided either horizontally or vertically. If it is for the floor, it is provided horizontally. If it is for the wall, it is provided vertically. The best location of DPC lies at the plinth level of the structure. As you can see in this figure, the damp proof course is provided at the plinth level so that there is capillary cutoff for the moisture entering from below into the substructure. So this damp proof course is cutting off the moisture that is entering from the soil. So this is the best position for the DPC. If some structures are not provided with a plinth level, in that situation, if there is no plinth, then we provide the DPC at 15 centimeters above the ground level. If this is a ground level, then it is provided at 15 centimeters above the ground level. Okay. Moving on. The second method is by surface treatment. The pores in the materials are exposed to moisture. These pores are filled by painting with water repelling compound. This treatment is called as surface treatment. So in this particular method, water repellent compound or substance is applied on the surface. Water repellent compound can be calcium and magnesium oleates, spirates. Both of them are very effective for the areas which has high rainfall. And we can also use bituminous solution, cement coating, transparent coating, painting, distempering as well. Commonly used surface treatment is lime cement plaster. The lime cement plaster has a proportion of cement lime sand proportion is about 1:1:6. That means 1 part of cement, 1 part of lime and 6 part of sand. This is very effective in preventing of dampness. Going on to the next method. The third method is by integral waterproofing method. In this method, certain compounds are added to the concrete or mortar during the process of mixing. This compound acts as barrier to the moisture penetration. This compound is available in powder form or it is also available in liquid form. In this picture you can see that while the concrete is being poured, the concrete is already mixed with the waterproofing compound. This compound, what is the quantity of the waterproofing compound to be added here is, it depends upon the manufacturer recommendation. Manufacturer is going to recommend the amount of waterproofing compound to be added in the concrete or cement mortar. It is normally 1 kg of waterproofing compound is added to 1 bag of cement. That is a normal proportion that is followed. The waterproofing compound can be alkaline, silicates, aluminium sulfate, calcium chloride. These compounds reacts with the cement and fills the pores and they act like the water resistant material. The next method is by special devices, that is by providing cavity walls. In this picture you can see the cavity wall here. So what is a cavity wall? The main wall of the building is shielded by an outer skin wall. This is the main wall of the building. This is being shielded or guarded or protected by another wall, outer wall. So this is also called as outer leaf, outer wall or outer leaf. A cavity wall has a hollow center. You can see in this picture, it has outer wall, inner wall, and in between these two walls there is hollow center. A cavity wall consists of two parallel walls or two leaves, as I told you earlier, separated by some amount of space or cavity, that is hollow center. The cavity prevents the dampness entering into the inner wall. If there is dampness at the outer wall, it is not transmitted inside through the cavity. The moisture never reaches the inner wall. That is a speciality. That is why this is used for prevention of dampness. So what is the specification? What should be the thickness of outer wall? What should be the thickness of the inner wall? The outer wall thickness should be 10 centimeter and the inner wall thickness should be minimum 10 centimeter or it can be more. And the cavity thickness should be around 5 centimeters to 8 centimeters. This type of cavity wall construction is most effective for prevention of dampness. There are a lot of other advantages of providing cavity walls. Better living, comfort condition. It is economical also, and it also provides good insulation to heat and sound. So moving on to the next method, uniting or short concrete. It consists of depositing under pressure. In this method, we deposit the cement mortar under pressure onto the surface, export surface, and this shot, whatever the cement mortar that is getting shot, acts like a water repellent or waterproofing. This consists of depositing under pressure an impervious layer of rich cement mortar over the exposed surfaces of for waterproofing. Here, the cement mortar of 1:3 proportion, that is, 1 part of cement and 3 part of sand is mixed, and it is shot on the cleaned surface with the help of cement gun. It is shot under a pressure of 2 to 3 kg per centimeter square. And the cement mortar is shot on the surface, wall surface, from a distance of 75 to 90 centimeter. And the cement mortar which is shot on the surface is brought to the required thickness, and it is cured for minimum of 10 days. And the last method is pressure grouting or cementation. Cement grout is forced under pressure into the cracks, voids, etc. that are present, the cracks present in the structural component of the building. This method is called as pressure grouting or cementation. In uh, this method is most effective in the cases where there is seepage of water through foundation and substructure of the building. If there is the moisture content entering into the foundation through the soil, this is the best method for preventing that particular dampness. So this is about the methods of prevention of dampness. Now, this is the end of topic. Let's now summarize the whole presentation. The first topic which we discussed today was effect of dampness. I think it is pretty much clear, but I'll just summarize because I did not summarize after every slide. So now I'm going to summarize the whole presentation at once. Effect of dampness. How is the dampness? You have studied how the dampness is caused. Now we are studying about the effect. After causing of dampness, what is the effect? What is the ill effect of the dampness? So the first ill effect is the wooden members are going to rot in the building. The second effect was corrosion of metal. The metals are going to get corroded. Metal, we are definitely going to use a lot of metal in construction. They are going to get corroded because of the dampness. And the third effect is it gives dampness gives rise to breeding of mosquitoes and creates unhealthy conditions. Dampness also creates patches, colored patches on the surfaces and ceilings. Electrical fittings may fail, that may result in electricity leakage, short circuiting, etc. Dampness also causes growth of termites. It actually accelerates the microbial activity inside the building. Dampness also results in softening and crumbling of plaster. Plaster will come out. Replastering is not that very easy to do. Then the bleaching and flaking of paint, which gives rise to white patches. It may also cause efflorescence, which results in disintegration of stones, bricks, tiles, and any other material used for construction. The fluorine might get loosened, the tiles might get loosened. Dampness breeds germs of dangerous diseases, as I told you earlier, tuberculosis, and the occupants may also become asthmatic because of the dampness in the building. So, this was the first topic we discussed in this session. The second topic, I also explained these pictures. I hope you all have understood the topic. The next topic we discussed was the method of preventing dampness. The first method we discussed here was by providing damp proof course. This is pretty much clear. This is very easy. We are providing a damp proof course. That course is a continuous layer of impervious member. Impervious means which does not allow the water to pass through it. That is called a impervious layer, impervious member. So in this method, we are providing an impervious layer in between the sources where from where the moisture is entering and the building. So it acts like a impervious layer. It does not allow the moisture to pass through it. So as I give the example of bitumen, mastic asphalt, bituminous felt, metal sheet, cement, concrete. So all these are the materials which we are using for damp proofing. These material about these materials we are going to discuss in the next session. DPC can also be provided horizontally and vertically. The second method is by surface treatment. In surface treatment, as we discussed before, the pores of the material exposed to moisture is filled by painting with water repelling compound. It's not just any paint, it is water repelling compound is painted on the surface which is exposed to dampness. So water repelling compounds may be calcium and magnesium oleate, stearates, bituminous solution, cement coating, transparent coating, painting, and distempering. The next method is by integral waterproofing method. In this method, the waterproofing compound is added to the cement mortar during the mixing. So the compounds can be alkaline, silicate, aluminum sulfate, etc. So this compound which we have added during the mixing of cement mortar that acts like a barrier. It does not allow the moisture to pass through it. The next method is providing cavity walls. As we discussed here, this is the outer wall, this is the inner wall, and in between the outer wall and the inner wall there is a cavity, the empty space. Or it can also be filled with less density, low density material. So this is called as a cavity wall. Cavity wall is a type of wall that has a hollow center. They can be described as consisting of two leaves. So inner wall and outer walls are also called as leaves here. They are separated by hollow space. The cavity prevents the dampness. So the moisture may enter through outer wall but it will never reach the inner wall. That is the concept here. The next method is uniting or short concrete. This consists of depositing under pressure the rich cement mortar. Rich cement mortar is taken in the cement gun and it is shot. As you can see in this picture, it is a cement gun and they are shooting the cement mortar, rich cement mortar into the spaces under pressure. The next method is pressure grouting or cementation. Normally the structural components will have certain voids, cracks, etc. Those cracks or voids are filled or forcefully filled under pressure with cement grout. That is the method. That is the method called as cement grouting. So this completes the today's topic. And for detailed information about this particular these topics, please refer the notes. And now let's discuss about the multiple choice questions. The first question here is the method of damp proofing in which a layer of water repellent substance is provided between the source of dampness and the structure is known as. Can you guess the answer? Answer is damp proof membrane. A is the answer. Let's move on to the second question. Dampness results in, what is the answer? Does it strengthen the concrete? Does it strengthen the plaster? Does it help in adhesion of paint surface? No. It helps in growth of termites. B. B is the answer. Third question. Dampness of roof may be due to insufficient lab of covering material, use of porous material, bad workmanship in plumbing, or any of these. Looks like any of these, right? So all these can be the causes for dampness. The fourth question, BTC should be, damp proof core should be continuous and unbroken through the length and thickness of the wall. Yes, that is right. It should be continuous, unbroken. Sealed with bitumen at lap joints. Yes, as we already learned, we have lot of bituminous materials. We use lot of bituminous materials for dam proofing. Bituminous felt, asphalt, mastic asphalt. They all are bituminous material. Sealed with bitumen at lap joint. Okay, yes. C is even. D is all of these. Yes, the answer is all of these. And the last question, in horizontal DPC, damp proof course, damp proofing, the thickness of cement concrete 1 is 2 is to 4. Usually, what is the thickness of the DPC for this particular proportion of concrete? That is the question. So the answer is it should be 4 centimeter. 4 centimeter should be the thickness of damp proof course. So here, this is the end of multiple choice questions. I have provided the key answers to all these multiple choice questions. Please go through. We have the references, all these content for the notes and for the PPT. I've taken the content from the following textbooks and other e-learning sites. Building construction textbook by BC Pumnia, a building construction textbook by PC Varghese, building construction by S.A. Rangwala, building construction and material by Guru Charan Singh, building construction by Sushil Kumar, construction technology by H.S. Vishwanath, Wikipedia of course, www.aboutcivil.org, www.civilengineeringnotes.com. For more detailed content, you can go through all these textbooks and other website information I have given in this slide. This content has been created by the following people. And thank you for attending this session. If you like this session, please rate it and like it. And please do attend the next session without fail. Thank you.